Hi, my name is Jake Audette. I'm going to be taking the test today. I'm going to be doing question 3. The first one says an operation with a large toaster has an ambient current at 3.9A. Find the toaster's average power. Okay, first I'm going to be making an AC circuit over here. It's the VRMS, which equals 120 volts. And there's a resistance here. And this little squiggly line right here, which represents trying to think. Okay, so we're gonna use the average power formula for the AC circuit, which we don't know anything over here other than the 120 voltage, but we are looking for the P average. We're looking for the P average, okay. The P average formula is voltage root mean square times current root mean square, which is 120 times 3.95. And that is 474 watts. Okay. Yeah, and your volt, okay. Just making sure. Okay, yeah. So there's our first wattage. I'm gonna fill this in as we go, because I know. Oh, this is the AC voltage source. I was like, what is this? I completely forgot. AC voltage source. There's our resistance, our voltage, root mean square, and yeah, we just found our P average, our average power. Find the toaster's maximum instantaneous power. Well, we're gonna do the power equals the voltage max times I max of sin squared watts T, which P max equals, gives us 2 times 120 times 3.95, and that equals 948 watts. Okay, which therefore gives us our power max. It's our instantaneous power, okay, because we plugged in, okay. Luckily we don't need anything over here yet, but see, we are definitely going to. But we just found out, okay, no, we are given our, I forgot to add it here, our current RMS, which is 3.95A, which is right here, okay. But now we're finding our resistance for C, which is a resistance equals voltage root mean square over the current root mean square, which is 120 over 3.95. Oh, just taking that recording, okay. Which equals 30.4 omega, which is our resistance. And basically our outlet sends the alternating voltage, and current will flow back and forth through the resistor. Okay, just making sure. All right, moving on to D, which asks us, an LCR circuit has a source of the voltage. Find the inductive and capacitive reactances. Okay. Well, again, we're gonna make a LCR circuit. Ooh. And we have our resistor right here. We have a gap right here. And we have a resistance, and then here we have our AC voltage source. So in this, we are given our amplitude and the angular frequency, which is 35V for our frequency and, for our amplitude, and 1.3 times 10 to the 3 rad s for our frequency. And we're given our resistance right here, 275 omega. And we're given our L, which equals our reactance. We're given, where's it at? The inductance, which is 82.3 mH. And is there anything else? They gave us the capacitance. They gave us the capacitance at C equals 1.2. Okay. I think that's it. Gave us a lot there. A lot to fill in. So now we are looking for is the inductive and capacitive reactances, which will be XL and XC. Okay. Well, the formula for the inductive reactance is the watts times the inductive, and for this one it's 1 over the watts, times the capacitance, which equals 1.3 times 10 to the 3, 0.0823, and 1 over 1.3 times 10 to the 3 of 1.10 times 10 to the negative 6, which comes out to 107 omega, and we have 699 omega. Okay. And this is an LCR circuit, by the way. LRC, sorry. Okay. Okay, I think that's it. And then for E, it's asking us to find the phase angle. For the phase angle, since we have an inductive and capacitance, we have to do tangent, and the tangent is going to be tangent equals XL minus XC over the resistance, which comes out to the L minus C, which is going to be negative 592 over the resistance, which is 275, equals negative 2.15, and we have to do the tangent, so we do tangent inverse, which comes out to negative 65.1, and that's our phase angle. Don't really add that in there, but yeah. F is asking for the power factor, which is even easier. All we do is plug that into cosine, the power factor, 65.1, which gives us 0.42, which is our angle. Checking I'm still recording. Awesome. Okay. Sorry, let me just fix this. Moving on to G. Find the circuit in the preceding problem. Find the impedance. Okay, for the LCR circuit, the impedance is going to be Z equals square root of resistance squared plus the X impedance minus X capacitance squared, which we can just plug our numbers right in. At least that's what I'm going to do. 107 minus 699 squared, which is going to come out to 653 omega. Okay, a lot of steps to this one. The circuit in the preceding problem, find the current amplitude. Okay, this one we can definitely throw in to our graph when we get it. Okay, the current amplitude formula is just pretty sure it's just I max. Yeah, I max, which would equal the velocity max over the Z we just found, which is 35 over 653, which therefore equals 53.6. Okay. We'll go ahead and plop that right here since we found our current, or well, the amplitude. And now we just have I. But I asks us to find the average power delivered to the resistor, which again, average, maybe I, this time squared, root means squared times the resistor, which is going to be 0.03779. No, sorry, just 79. Squared times 275, which is going to equal 0.395 watts. Okay. Moving on. Just checking the thing. Okay, we have J. We're gonna make a different graph for this one. J, which asks for find the inductive and capacitance reactions. Okay. Well, for this, we have, okay, so it's just asking us to find the inductive and the capacitance again, which again is watts. L and L is 1 over watts C, which is going to be 1.3 times 10 to the 4th times 9.5 times 10 to the negative 3 equals 7.5 omega. And for this one over here, sorry, 1 over 1.3 times 10 to the 4th times 440 times 10 to the negative 6, which equals 175 omega. And we're gonna make our graph real quick. Ooh. Down, here's our resistor. Here's our capacitance. No, not resistor, but our capacitance. And we have another one, and then here is our AC voltage sortage. In the problem, we are not given the resistance, but it goes right here. We are given our capacitance though. And we are given, our frequency is again 1.3 times 10 to the 4th. And our series circuit is 0.800. And we are given our inductance. Here we go, inductance is right here. Okay. And then we just found our inductive and capacitance. Okay. So all we have left, I'm gonna finish the two problems down here. Okay. Find the phase angle. Phase angle. For that, we do the power factor. Yeah, like, what was it again? Do the power factor, which is cosine of the angle over the number, and it's going to be cos inverse of 0.800, which comes out to 36.9. And it's going to be negative because it's pointing in that direction. The phase angle is, the phase angle is pointing in the negative direction. So it would be positive, but because that's negative. And then we have L. And for L, S is to find the resistance, which in turn, it's gonna be, pretty sure, resistance is voltage max over the amplitude max, which in turn, our thing, where is it at? J, okay. Voltage max. Have a voltage in this. But I know it comes out. Yeah, it's gonna be. I don't know about this one. I don't know. For L, I don't know the answer to it, and I'm sorry. Here is the answers for the rest. And thank you so much for watching.